Hello, welcome back. We're going to look at insertion sort. Let me first start with an example. Okay, so the numbers, I'm going to give a list of numbers and we're going to do the insertion sort. Okay, so this is my set of numbers and we're going to do insertion sort. And the idea of insertion sort is it's like you sort a deck of cards in your hand. What you're going to do is you're going to take one card and you're going to place it where it's where it's going to fit in. Okay, you're going to take one and put it there. That's the kind of idea which we'll go through it in detail. Okay, so first we are going to assume we're going to start from here. So initially I'm going to we are going to consider like sub arrays like this, where I'm going to first look at take this sub array, so which is only this 0th index, and I'm going to assume that it's a sorted array. It's a sorted array, right? Because there's only one element, right? So it's a sorted array. Now I'm going to just move here. So there's just this extra element which I'm going to place it in its location. Okay, so you'll soon see what I'm trying to say. So I'm going to write a sequence of what happens at each stage of the sorting. So initially 23 will be like this, will be considered as a sorted array, and next we move on to this 17. What does 17 do? 17 is obviously smaller than 23, and therefore we are going to place 17 before 23. So we will get now this much is a sorted array, right? Right. Now we have a sorted array till here. Okay. Next array element we are going to look at is this 10. What do? Where should 10 come in 1723? It has to come there. Okay. So what the main idea is, I'm going to put 10 here and we will push 17 and 23 here. Okay. This is what we will do. It's clear what? Okay. So I'm going to push this. Okay. So maybe okay, so 10 is going to come here and 17 and 23 gets pushed to the side. Now till this much is sorted, right? Till this much is sorted. Next we are going to look at 25. Okay, so 25 where should we place? In this array, it has to be in this end. So 25 is just copied here because it's not going to be affected. Okay, so it's actually not copying because we are going to work with the same array here. Okay, now we are in 20. When I look at the another example, we'll go through it again. So here is 25. Next we are going to look at 87. Where should 87 come? Okay, 87 also should come next. So we haven't modified anything. Next is, where are we? We have to look at 61. Where should 61 come? 61 should come here, right, in the place of 87. So I'm going to copy 61 here and push 87 that side. Finally, we have 20, right? So till here it's sorted and now we have 20. Where should 20 come? 20 has to come here. So we're going to push all these guys to this side. So let me do that. First I'm going to push 87 this side. 87 comes here and 61 comes here. 25 comes here. 23 comes here. And 20 comes here, right? Now this is my insertion sort. Okay, so let me go through it again, and let me take another example and go through it again. And this time I'm going to work it with the same array. I'm going to do the same thing in this current array. Okay, and this time we'll also I will also see how to place. How are we going to place? How are we going to do the shift and and correctly placing the next element? Okay. Right. So let's look at another example. Okay, this is my array, and let's start from the beginning. Okay. So we're going to 50 is a sorted array. Just 50 is a sorted array. Next we move here 17. Okay, we are here now, and we know that before 17 this much is a sorted array. And what I do is I compare 50 and 17, and I know, okay, this has to be swapped, right? 70 has to come here and 50 goes there. Okay, so we'll just do the swap. Okay, next we move to 29. Okay, so what is it we are going to do? We are going to place 29 in the correct place, required place. Okay, and to do that, what we do is that we check for first 50 and 29, and since 29 is smaller, we swap. Okay. Next we do 67. 67 and 50, nothing to swap, so it remains there. Next we go to 53. 53 and 67. So every time I am assuming that this much part of the array is sorted, and that's sorted because that's what we have preserved. Now 53 and 67, they have to be swapped. Next we come here 11. 11 and 67, swap. 11 and 53, swap. Okay, so we keep on swapping it until it falls into the correct place. 11 and 50, swap again. 11 and 29, swap again. 11 and 17, swap again. Okay, so this is how we are going to implement insertion sort. In the previous thing, I said that okay, you place it in the where an element goes and then shift the entire thing. You could have implemented like this, but the swapping is much more easier to implement. Okay, so now let me write an algorithm for this insertion sort, and then we will try to analyze its running time. Okay, what is the input? Input is going to be an array. Insertion sort. Okay. Now, first thing, it's going to be a for loop, right? Okay, so first point in the array is going to be considered as the so AR of 0 is now, that's considered as a sorted array, and we're going to start from AR of 1. Okay. What is done now? Once we do this, I'm going to basically look at AR of I, right? In this for loop, I'm going to look at when I look at AR of I, I'm assuming that all this previous thing, AR of 0 to AR of I minus 1 is already sorted, and I'm going to place AR of I in the best position possible. So I'm going to swap until I reach the position, right? Okay, so let's write a function for that. Sorry, let's write another while loop for that. Okay. Okay, so maybe we can write a for loop also. Okay, and here what we are going to do is the following. So AR of j is okay, or I'm going to start from I, and I'm going to write I j minus 1. Okay, so that means the previous array element is greater than AR of j. We want to swap. So I'm going to write a function to swap. So a block of code to swap them. Okay, let's just write that. So I just pass these pointers and write a function swap to do this swap. Okay. That's inside the if statement. So if there is a place to swap, I swap. Otherwise, if there is nothing, I just, else means you can't swap, then you just break out of this for loop. That's all. This is our insertion sort. And if you want to work this out, let's just quickly go through it and see whether this is what we are interested in. So let me just write some integers and see. Okay, before that, I want to, before we go into an example, let's try to analyze its running time. We have seen this kind of analysis. The outermost block is going to take n steps, order n steps, and inside block, this is something we saw, right? This in the worst case, so we have to analyze always the worst case running time. The worst case running time, this entire for loop is going to be executed. And I know each time I start from I, this is I, not 1, okay? Each time I start from I and end in 0, right? So since that is the case, what happens? So the number of, how many steps does this if condition execute? So initially when I enter, it's 1, so 1 step. Next, it's going to be 2 steps. Next, when I becomes 3 steps. I becomes 4. This goes from 4 to 0, so 4 steps, right? And finally, when I becomes n minus 1, this takes n minus 1 steps. These are all worst case, I'm saying, assuming that this break does not get executed. What is break? Break basically takes me out of this for loop, right? This is a C syntax we are using. If you I mean, you're not familiar with break, you can use a while loop here and then come out. Okay, or use a flag here and use a flag in this condition. Not just j greater than 0, you should also have a flag there. So there are multiple ways to come out, break out of this for loop. Okay, so now so finally when I is equal to n minus 1, this in the worst case, this for loop gets executed for n minus 1. So this many steps get executed, and we know the answer to it. This is order n square. We saw this fact, and that's insertion sort. Okay, running time analysis, in the worst case running time of insertion sort is therefore order n square. Some questions to consider are, how much extra space does it take? It does not take any extra space. No new array is taken. Maybe some ij, some constant number of space. So the space is order 1. Space requirements is order 1 and time complexity is order n square. Space complexity is order 1. Right. Okay. Now, good. Now let's go to let's look at an example and finish this. Okay, I just took some few numbers. So initially it's 10, and so that's fine. This is 0, the index, so we are okay. This is index 0. So we are going to start our running from index 1. So we go to index 1, and what happens? So my I is 1. I is equal to 1, right? I is equal to 1. And now I start my j from I. Okay, and I compare j minus 1 and j. So I compare. So j is 1, so j minus 1 is this thing. So 10 and 23 I compare. And j minus 1, if j minus 1 is 10, is this true? It's not true. Therefore, we break out. So that for loop is over, right? We break out of that for loop. Okay, so now, so this for loop gets, and then we go again, and I moves to I is equal to 2. Okay, and now again j starts from 2. Okay, and we compare j minus 1 and j. So we compare AR of 1. And indeed, it is true. AR of 1 is greater than this thing. So we swap. And swap, and then we go back here. J minus 1 minus happens, and this becomes 1. In this case, again, I come. So j is 1, and then I do j minus 1 and j. Is this true? This is not true, right? So we break out. Okay, even if it did not have broken out also, this for loop would have ended and we would have come out of that for loop. Anyway, so we are now back to I is equal to 3. So j starts with 3. We compare j minus 1 and j. And it is bigger, so we swap. That's it. And next j becomes equal to 2. And this is 1. This is 2, and there's nothing to do, right? So swap has, this is not going to get swapped. Okay. Finally, I is equal to 4. J is equal to 4, and we come in here and see that 3 and 4, this is not true. So swap does not happen, break, we come out of the for loop, and that's it, done. Right? We have a sorted array here. Okay, so this is insertion sort for you. Thank you.